Welcome to this lecture. In this lecture, we are going to learn about linked list. Linked list is a data structure. It is a collection of nodes that are connected together via link or address. A collection of nodes. Each node consists of two parts. Part number one is data part, contains our actual data or information, and the second part is the link part. It is a pointer which holds the address of the next node. Pointer is a variable. The address of the first node in the linked list is kept in a pointed head. The link part of last node contains a null value. Here is the pictorial. This is head pointer which stores the address of the head node, which is here. The head node is the first node in the linked list. So the combination of data and link is called node. So the here information over data is here, which is 1, and the link part that contains link of the next node. So head pointer stores the address of the head node, which is A3 in head pointer, and in head node the first part, which is data part, according to our definition, contains our actual data, here 1, and in link part, which is pointer type variable, and it stores the address of the next node, which is A2 is the next node. Basically A3, A2, A1 are the addresses of the node. So in second node, data is here, which is 2, and the address is A1 is here, which is the address of the third node. And in last node, according to our definition, the link part of last node contains a null value. So here is the null value because this node is the last node in a linked list. Linked list versus array. Here head A1 data and link part. This is first node. A1 is the address, A2, A3, A4 are the addresses. So and A5 is the last address of this node. So we can store data into linked list like this way. But in array, here is the representation of the array, contiguous memory location of the same data type. But linked list is different from the array. And here are the advantages and disadvantages of the linked list. So disadvantages of linked list are here: no direct access. We cannot access directly any node. So unlike array, we can access the value of array by using index. So by using A3, we can get the value of A3 index, but here we do not know the address of the node because it is dynamically allocated address. So in array, we can access any element by using the address of or by using index of the array. Reserve more memory than array because it contains data and link together. So it is reserve more memory than array. Advantage is it can be made just as long as required because it is dynamic data structure. So we can dynamically allocate the memory. So linked list by using struct. So we can create struct. Struct is the data structure which contains the multiple data type values. So int data, which means that we are going to store our information in the form of integer, like according to our pictorial form, which is here. And the second one is struct node static link, which is a pointer variable or pointer struct, which will store the address of the struct node. So this is all about linked list introduction. Now we are going toward implementation. Here create a global struct node and int data, and here is struct node link. Save it, and after that create 3 nodes. So for that, struct node, first of all head and store null initial value, and struct node A. You can assign any name, but name should be valid. Struct node B and is equal to null. Now how we can allocate the memory? So because where is the link of the next node? So for this we are going to use malloc function, which is memory allocation function, which allocates the memory in the heap section of the RAM. So here head address, our head address memory, which is equal to struct node static malloc size of struct node. So here we are going to allocate the memory for the head. So here we are going to tell malloc function that the first parameter, that is we want to store address of the struct node type data, which is here struct node. So malloc function, which means memory allocation function, determines the size of the struct node and then allocate the address to the head. And same case with the node A and node B. Just node A, here node B. So here by using static and head dot data, we are going to access, this is the static which indicates the, we are going to fetch the head dot data. So head refers to the this data because head is a data type of struct node and we can store the value of 10 in it, or we can use alternative way, that is hyphen and greater than sign, and just remove this stuff. So if head is the last node, then store null into the link, and if head is not the last head, then store the address of the next node, which is node A, and copy this one and paste it here. Node A, node B, the value of node B is 20 and address as node B. So 30 store null because it is the last node, and node B, node B. So save this one, run and compile. So here is the result. There is no error in our program. So now we are going to create a function void show data struct which receive node struct node pointer, and by using while loop we are going to display the values. So here node not equal to null, it means that this is last node, and stop the loop. And by using print f function we can display the value of the node data, and node data like this, and the next node is node link. Just simple copy the function and like that run the program, and 10, 20, 30 are the values, and just here Control T for tab and run the 10, 20, 30 are the values. 10 in first node, 20 in second node which is node B, and 30 in which is node A, and 30 in node B. So show data sends head which is first node, and then here we are going to receive struct node static which is pointer and pointing toward the struct node like this node, and then if node not equal to null, it means that node contains values. And printf, we are going to print the node data, and here node is equal to node link. Thank you for watching this video.